In this problem, we're going to analyze a quadratic function whose leading coefficient is negative. I want to analyze the function f of x equals negative 2x squared plus 4x minus 5. First thing we'd like to do is determine whether the graph opens up or down. We do this by looking at the coefficient on x squared. Since the coefficient on x squared is negative, we know that the graph will open down. Next, we want to find the vertex of the graph. We can find the x-coordinate of the vertex by using x equals negative b over 2a. We come back up to our function. We can identify that a is equal to negative 2, b is equal to 4, and c is equal to negative 5. So it'll give us x is equal to negative 4 over 2 times negative 2, which is negative 4 over negative 4, which equals 1. We can get the y-coordinate of the vertex by evaluating our function at x equal to 1. That is, we need f of 1, which is negative 2 times 1 squared, plus 4 times 1 minus 5. 1 squared is 1. Negative 2 times 1 will give us negative 2, plus 4 times 1, which is 4, and then minus 5. Negative 2 plus 4 is 2. 2 minus 5 is negative 3. So our vertex is the point 1 comma negative 3. Next, we want to determine the axis of symmetry for the graph. The axis of symmetry is the vertical line that passes through the vertex. We found that the x-coordinate of the vertex was 1, so our axis of symmetry will be the vertical line x equal to 1. Next, we're going to find the intercepts of the graph. We'll find the y-intercept first by evaluating our function at x equal to 0. That is, we'll find f of 0. So it'll be negative 2 times 0 squared plus 4 times 0 minus 5, which is just equal to negative 5. If we look back at our function, we notice negative 5 is the constant, so we could have found the y-intercept just by looking at the constant for our function. Next, we need our x-intercepts, so we'll just write y-intercept there. To find our x-intercepts, we're going to set our function equal to 0 and solve the resulting equation. So if 0 equals negative 2x squared plus 4x minus 5. We'll solve this quadratic function, this quadratic equation. We noted earlier that a was equal to negative 2, b was equal to 4, and c was equal to negative 5. So we can use our quadratic formula. First, we're going to find the discriminant. That's b squared minus 4ac. So it'll be 4 squared minus 4 times negative 2 times negative 5. So we'll get 16 minus 4 times negative 2 is negative 8. Negative 8 times negative 5 will be a positive 40. So we end up with 16 minus 40, which is equal to negative 24. Since the discriminant is negative, the solutions to our quadratic equation will be imaginary, so we have no x-intercepts. Next, we want to use the information that we found in parts A through D to graph our quadratic function. And once we have our graph, we're going to use it to determine the domain and range of the function for part F, and in part G, determine where the function is increasing and where it is decreasing. So we're going to go ahead and graph our function. Here we have our grid that we're going to use to graph our function, and we've already put in our scale. In the x direction, we're going to scale by 1, and in the y direction, we're going to scale by 2. The vertex was at 1, negative 3, so x is 1. We move down to negative 3. Remember, our scale is by 2. So we have the point 1, negative 3. We had a y-intercept of negative 5. So we'll plot the point 0, negative 5. We'll put in our axis of symmetry. It was the vertical line, x equal to 1. We could plot one other point using our y-intercept and the symmetry of our graph. Since the point 0, negative 5 is 1 unit away from our axis of symmetry, we go 1 unit in the other direction. We'll have the point 2, comma, negative 5 that will be on our graph. We'd like to get maybe 2 other points to get a nice smooth curve. So we're going to pick, let's say, x equal to -1. Remember our function was f of x is -2x squared plus 4x minus 5. If we evaluate at -1, we'll have -2 times -1 squared plus 4 times -1 minus 5. -1 squared is 1. -2 times 1 will be -2. Then we'll have 4 times -1, so we'll have -4 and then minus 5. So this will be -11. So the point -1, -11 will be on our graph. Again, we'll use symmetry. This point, -1, -11, is 2 units away from our axis of symmetry. Go 2 units the other direction. And we'll get the point 3, -11 is on our graph. And here we'll connect these points with a smooth curve. And extend our graph. So we'll have the graph of our function, -2x squared plus 4x minus 5. Now in part F, we were asked to find the domain and range from our graph. The domain is a set of values for the independent variable x. And looking at our graph, we can see that will be the set of all real numbers. Or in interval notation, we write -infinity to +infinity. The range is the set of all values for the dependent variable, in this case y, it's our output. You can see that we can get all values for y that are -3 or less. So we'll say it's the set of values for y such that y is less than or equal to -3. Or in interval notation, we would write -infinity to -3. We'll use a square bracket on -3 because we can include that. In part G, we're asked to find where the function is increasing or decreasing. We're looking for x intervals here. Our graph, we can see starting at the left, the function is increasing on the interval -infinity to 1. That is for x from -infinity up to x equal to 1. And then the graph begins to decrease starting at 1, and it continues to decrease as x goes to infinity. Note that we use parentheses for both of these intervals. When we determine where the function is increasing or decreasing, we will use open intervals only, because at this transition point, function is neither increasing or decreasing.